Okay, so this is balancing equations, and this is in your booklet. I just wrote it up here so you can see. So the law of conservation or mass or conservation of matter, all that means is it has to have the same on both sides. So over here on this side, these are the reactants. These are like the ingredients to a recipe. This is what gets it started. Over here, these are the products. That's what you take home. That's what you're left with at the very end, okay? Something I do, you don't have to do, but I put a line down the middle so I can compare, do I have the same number of atoms on the reactant side as the products? It's very, you kind of go back and forth like a teeter-totter, because when you put a big number, which is called a coefficient, in front of the equation, it affects all of them, not just one of them. So right now I want you to write down how many atoms you have on each side. So I have 2 Fe's. How many oxygens do I have? I have 3 oxygens. And how many carbons? Just 1. And on this side, I have 1 Fe, 1 carbon, and how many oxygens? Okay. And is anyone confused as to how did I get those numbers? How do I know I have 2 oxygens? Okay, because this little baby number, whatever it's attached to, means that's how many I have of them. Are these even? Are these sides even? No. Okay, what do I need on this side? We'll start there. I need some Fe's, okay? Because this side has 2 Fe's, I need another Fe. So I'm going to put a 2 here. When I put a 2 there, it does not mean add 2 more Fe's. It means that's what you have in total. When you read the equation, I can look at it and it says, okay, this means I have 2 Fe's. So when you do add these coefficients, the big numbers in front are called coefficients. When you add them, it doesn't mean you add 2 more, it just means you have 2 total. So you have 2 Fe's, 2 Fe's. Okay, there's 1 C, 1 C, but my O's, my oxygens, are not equal. It's always sort of a challenge when you have an odd number and an even number, and I'll show you why. So if I put a 2 here, okay, this gets multiplied by that. So that would give me 4 oxygens. And then it would give me 2 carbons. Well, now it messed up what's going on over here, and there's no number I can put right here that would give me 4 oxygens because it ends in a 3. So I'm going to take this back, and you're going to scratch out a lot on your paper today, unless you have a pencil. Okay, I'm going to go ahead and put a 3. So that gives me 3 carbons, because that 3 affects both of these letters. It gives me 3 carbons, and it gives me 6 oxygens. Okay, 3 carbons, 6 oxygens. What number can I put right here to give me 6 oxygens? Right, if I put a 2 here, okay, remember, this little baby thing is called a subscript, and it gets multiplied. Like whatever the coefficient is, you multiply it by the subscripts. So I have 6 oxygens, and I have 6 oxygens over here. But by putting that 2 there, it changed the ions, the Fe's. How many Fe's do I have now? 2 times 2. Now I have 4 ions on this side and 2 on here. What do I have to do on my product side? Okay, and we're done. I have 4 Fe's, 4 Fe's, 6 oxygens, 6 oxygens. Oh, but my carbons. That's right. What number would I have to put there? 3. Do you guys have any questions, or do you see how we're doing this? The big number dictates and tells you how many atoms you have of each. Any questions? Okay. So now we're going to turn to our worksheet and practice. This is conservation of mass, which means the same thing. Conservation of anything means it has to stay equal. One side can't have more than the other side. The reactants you can't have an experiment and then end up with more than what you even started with. They have to be equal. They can be rearranged in different manners, but they're going to be the exact same. So if this is mass, when when you think of mass, I want you guys to always think of a scale, or think of grams, or think of your weight. Mass is always generally in grams. So I'm just going to put grams here. Don't forget to put your name. Don't forget to put the period. So we're doing the same thing. We're balancing the equations. They gave us an example right here. Sodium plus chlorine gives us sodium chloride. Then it's giving us the equation 2Na. Here's our balanced equation. Okay, so they kind of broke it down for us. I'm going to zoom in. What you're going to have to do is what we just did. You're going to, I personally put a line down the middle. Oh, they did too. Okay, and then you write how much of each you have. I'm going to change to a pen. So how many sodiums do I have? And this equation right here. Right, I just have one. What about oxygens? There's 4. Does anybody not see 4 oxygens? Because I have 3 right here and 1 here. Okay, so there's 4 oxygens. How many hydrogens? 2. Did I lose anybody yet? Are we good? Can we count the number of atoms? Okay, so let's go ahead and go to the other side. How many sodiums do I have on this side? 1. How many oxygens do I have? 4. See, there's 3 right here, and then 1 here. And then how many hydrogens do I have? 2. Because it's conservation of mass, we're going to use the weight. So you do need to grab your periodic table because we need to make sure that it's the same mass on both sides. You can use your phone or a calculator. Okay, so now I'm just going to add up this side and add up the other side. So sodium, how much does sodium weigh? Atomic number 11. Oxygen, how much does oxygen weigh? And hydrogen. Okay, so the only thing with oxygen, because I had 4, I do that times 4, and hydrogen's times 2, and I add them all up. So 16 times 4 gives me 64. 2 times 1 is 2. So I add up 23 plus 64 plus 2. So this side weighs 89 grams. And now we have to see how much the other side weighs. Is anyone confused or have any questions on how we're comparing mass? Okay. So on this side it's 23 plus 16 times 4 plus 2. Is it going to equal the same thing?
Yes.
Are these balanced? Is this a balanced equation?
Yes.
Okay, so you could, in essence, on multiple choice exams, you would put 1s here, and in the answer choice, it'll ask you what are the coefficients. Okay, that's how they're able to ask you in multiple choice exams, and the coefficients would be 1, 1, 1, 1. Because what it's asking you is we had 4 blanks, and it's asking you what the big numbers are. So on a multiple choice exam, it would be 1, 1, 1, 1. Okay. I'm going to go ahead and switch over to it's good practice there. Balancing and naming types of reactions. So flip the page over. And you're just going to, I always put a line straight down the middle. And then you just write how many of each you have. 1 NA, 1 BR, 1 CA. I have 2 OHs. Now the other side, I have 1 CA, 2 BRs, 1 NA, 1 OH. So I have more OHs over here, so I'm just going to start by putting a 2 here. I put a 2 there because I know I need 2 OHs. However, by putting that 2 there, now I have 2 NAs. So if I have 2 NAs, I go over here and I'm going to put a 2 here. So you see, you're going to be going back and forth a lot. So if I put a 2 there, I now have 2 NAs, but now I have 2 BRs. And the ones that are left blank, you could just put 1. Then you just compare. Is this equal 1 CA, 2 BRs, 2 NAs, 2 OHs? It's now a balanced equation. And on the very last page, you're just identifying types of reactions, which is what we've been doing in our booklet. Right away, again, the easiest ones, anything ends in H2O and CO2, what is it? Combustion. So number 15, I can tell already. Number 15, if it ends in CO2 and H2O. Combustion. I would write combustion right away for those. All right, and then if anything, I don't think we have any neutralization on these. I'll take a look. I'm going to leave this to you to get started. We won't be looking at our booklets today. You'll be working on this worksheet. We're going to be doing this today and tomorrow, and then a lab on Friday. This needs to be done by tomorrow, though. So if you need help, come and see me. You can rewatch this video. It practices 1 from each page. So you follow along, and from there, you're going to try to work your way through it.